quick review of yesterday's video notes. We started all talking about electrolytes. Okay? An electrolyte is a solution that conducts electricity. A non-electrolyte then would be a solution that does not conduct electricity, does not have a current flowing through. Now, if you look here, just the quickest way to test something is we have probes here that they are sticking into this circuit. Somewhere, I would say off down here at the bottom, is a battery. All right, we have a light bulb. We have a light bulb. Now, notice that the probes are not touching. The probes are not touching. So, in order for this light bulb to light up, the current has to be able to flow through that solution. Now, if you look, here's a light bulb. It is fairly bright. So we have good conducting of electricity right there. Here's a little dimmer than the first one. So this does not quite conduct electricity as good, but it still does. So it is weaker, a weaker electrolyte than the one on the right. Over here, no light bulb lit. That means that there is no conducting of the electrical current. Therefore, that is a non-electrolyte. Okay? It could be as simple as when we test these, okay, we use a little harness as so, and a little 9-volt battery. Okay, this has a little light bulb on it. We can stick, what I usually do is I put 2 paper clips on the end of the alligator clamps there and put the paper clips down into the solution. That's an easy test of an electrolyte. Okay, so whether it conducts electricity or not. Okay. Now, what are some factors that affect the rate of dissolving? We're going to do this lab. I think it's going to be on Monday. Okay, I think the lab will be on Monday, factors that are affecting the rate of dissolving. So what are some factors? Number 1, the surface area. Okay, if we have greater surface area, we have greater dissolving. Doesn't that make sense? If more is touching the surface, it dissolves greater. Agitating or stirring the solution, mixing somehow. I guess you could shake it. And finally, heating the solvent. Usually. I'm saying usually. Usually if we heat a solvent, it increases the rate of dissolving. Not always, but usually. Okay? If we look about breaking this down. Now, when we talk about the surface area and how it is affecting the rate of dissolving, you might not think it, but the surface area to volume is greater on which one of these blocks? The little one on the left or the big one on the right? The small one. So, things dissolve quicker if they're smaller, because smaller things have greater surface area. So if I have my coffee here and I throw a cube of sugar in my coffee, or I take that same cube and crush it all up and throw it in my coffee, which dissolves quicker, the crushed one or the cube? The crushed one. Why? Because its surface area to volume is greater. Agitating, we talked about that. Why does agitating speed up dissolving? What does that have to do with it? Gets the what moving? Gets the molecules moving. Let's say this is water, right? Let's say it's water. It gets those water molecules moving. If they're moving more, they're dissolving faster. What about temperature? What about temperature? About the same thing, right? If I'm heating something, what happens to the molecules? They're moving faster, okay? So if you look at this right here, and like I said, the majority of things, these are just solubility curves. We'll talk about these later on, okay? A solubility curve, you can see temperatures down here on the bottom. Most of the lines, here's 0, here's 100. Most of the lines are going up, okay? They're going up at different rates, but over the temperature increase, most of them are going up. Now, if you look, the dotted lines here are gases. So most gases are decreasing solubility if we heat them. Okay? If you look right here, here is sodium sulfate. Sodium sulfate is one of the solids that decreases solubility if it is heated up. Okay? So we can't say with 100% certainty, yes, if you heat it, it's more soluble, but most of the time, that is a true statement. Final thing we're going to talk about today, very quickly in our review, is solubility. Solubility is the amount of a substance required to form a saturated solution with a specific amount of solvent at a specified temperature. Now, the thing about solubility is you need to know the amount of the solute, the amount of the substance that's being dissolved. You need to know the amount of the substance that is doing the dissolving, and you also need to know what temperature that is being dissolved at. Because we just talked about how solubility changes with the amount of temperature. So, if I were to give you one, it would say, at 20 degrees Celsius, I can dissolve 87 grams of sodium nitrate in 100 grams of water. Now, on WebAssign, you'll have to vary these, okay? You'll have to vary these. So, what if I would tell you I had 200 grams of water? How much sodium nitrate could I dissolve? Okay, well, what's 87 times 2? Okay. 80, what is it? 174? Sound right? Okay. What if I would say that I only have 50 grams of water? Then I'd take half of that, right? I would take half of that. So we can use our knowledge of proportions to change those around, and you'll have to do that on WebAssign. Okay? Now, a saturated solution is a solution that contains the maximum amount of a dissolved solute. So I'm going to say right now that sodium chloride at 20 degrees Celsius, I can dissolve 35.9 grams of sodium chloride in 100 grams of water. We're going to use that. That is a saturated solution. That is the maximum amount of solute that I can hold in that amount of solvent at that temperature, 35.9. So, if I have an unsaturated solution, okay, that just means that it does not have all the maximum amount of solute dissolved. So if it's unsaturated, it would be anything less than that 35.9. So let's say I have 25.9. Well, how much more salt could I dissolve in that water at these conditions? 10 more grams, right? So that is an unsaturated solution. It has less solute than the saturated solution. Now finally, we get into a supersaturated solution. Okay? A supersaturated solution is a solution that contains more solute than a saturated solution under the same conditions. Now, this is always a struggle because, okay, by definition, we said that a saturated solution has the maximum amount, right? Well, this, by definition, says you have more than that. How is that possible? How is that possible? Well, if you are making a saturated solution, okay, a super saturated solution, you have played with some of the variables. The way that I do it the most, okay, the way that we do it the most in here is we heat that solution up. We know that certain solutions hold more at higher temperatures, correct? If we heat that up and then just take the heat off of it and gradually let it cool on its own, okay, it can still keep all of the solute in solution. Okay? It can still keep all of that solute in solution when it gets to temperatures where that shouldn't be. Okay? When it gets to temperatures where that shouldn't be. Now, for instance, if I look at this here, I say 100 degrees Celsius, I can hold 39.2 grams of sodium chloride in 100 grams of water. So what happens is I have this 100 grams, I heat it this, I dissolve this in this much water. Then all of a sudden I let it cool back to 20 degrees Celsius. Well, if it's not agitated, if it's not disturbed, that 39.2 grams of salt will stay in solution. Okay? Now, what could disturb it? If I took my pencil lead and touched the top of that surface, that could be enough to disturb that equilibrium in there and cause that to settle out. All right? Now, this video here, okay, this video was in your video. Was it kind of shaky? Was it a bad video? Okay? That's one thing that I haven't figured out yet of my making videos, of taking a video of a video. It always comes up bad. I don't know why. Okay? I don't know why. I wish I were smart enough to get that all figured out. But here is the video. I'll show you this. It's only 2 minutes. It's kind of good. The thing I like about watching this video, but one thing is they definitely need to work on their safety stuff. Okay? They definitely need to work on their safety. Okay? We got a dress code violation right there. That's a definite. Cell phones out. You know, during labs, all kinds of stuff we don't allow here. Okay? He's got a super saturated solution, okay, right there. Look, their teacher doesn't even have goggles on. Heathens, okay? Heathens there. But he's got a super saturated solution right there, and he just had a couple of flakes, a couple of crystals, okay? He's going to put this now into solution and disrupt it. All year. I don't think these people get out much. It does look neat, but I don't think that I'm going to go that crazy. So by adding that one crystal in there, it disrupted the equilibrium. Now, all of the solute that was above the amount at that temperature is coming out of solution. So, as you see this, now that liquid now is a solid. All of that has come out of solution. Okay. Okay. So now, what he just said there, he had them feel that, and he said, whoa, guess what? They said it's warm. So when that crystallized, you know what it did? It released heat. Okay? Well, how could that be helpful? How could that be helpful? Ever seen anything the likes of this? Okay. What's it look like? What'd you say? Is it an ice pack? Well, what'd they say happened there? It got hot. Okay? Parker's a baseball player. He knows that hand warmers are great in your back pocket on a cold day so you can keep your hand in here because you got to throw a baseball. Okay? You want to keep your hand warm, right? Okay? So you put a hand warmer in your back pocket. Now, this has a little plate. Can you see the little plate in there? About the size of a dime. It's not a dime, about the size of a dime. Okay? What I'm going to do is I'm going to disrupt the equilibrium by clicking on that plate. Okay? Feel that real quick so they say I'm not lying. It is a liquid, right? Does it feel hot to you? No, it doesn't feel hot. Okay? Now, I just clicked it. Can you see it? See it? Grab a hold of her. Just take it. A little bit warmer? A lot warmer. Okay? A lot warmer. Go ahead and pass it down. Pass it around. Huh? I don't know. Now, the thing with this too, folks, the thing with this and what that gentleman can do right there, okay? What happens if I would put heat back into that? Okay, what if I would heat that back up? What if I would put his beaker right there on a stove? Okay? What would happen is we would put that back into solution, and we could do the whole thing all over again. That's the great thing about those heat packs right there. What I'll do today is I'll put it in boiling water. Okay? It'll go back into solution, and by the time you get in here tomorrow and it's cooled down, it'll be the same way it was when Graham was squeezing it before. Okay? It'll be a liquid back again. So I can reuse those, Parker. I can reuse those many times, not like those junky ones that last about 20 minutes and then they're done. Okay? I could reuse that many times. Now, where I got that, I ordered it off a chemical like Flynn, a chemical company. So I don't know if you could get something like that anywhere, but you know, it's worth a try. It's called the Heat Solution, the reusable instant hand warmer, and it's made by Prism Technologies. Yeah, that helps, but it doesn't do you any good when you're out in the field. Okay.